Alright, problem C. Let's find the zeros of this function. In order to do so, we need the numerator of this fraction to equal 0. That's when a fraction is equal to 0. So, solve this for x. Alright, well then the square root of x plus 1 has to equal positive 1, which means x plus 1 has to equal positive 1 if you square both sides. Right? Boom, boom. X plus 1 equals 1, so x equals 0. There's my 0 right there. Now let's do the domain. Now the most obvious way to look at this and do the domain is to look at the denominator and say, I know that the denominator cannot equal 0. So I know x cannot equal 2. But the problem is you cannot stop there, because in the numerator we have a square root, and we know that we need the square root of x plus 1 to be greater than or equal to 0, because if it's less than 0 we get an unreal answer, hence problems. So go ahead and solve this. Square both sides. X plus 1 is greater than or equal to 0 still, so x is greater than or equal to negative 1. So how do we state this? We know we're not 2, and we know we're greater than or equal to negative 1. Let's do set builder notation. We can say that x in R such that x not equal to 2 and x greater than or equal to negative 1. It's not very graceful, so let's try interval notation as well. X is in the interval. I know I have to be greater than or equal to negative 1, yet I cannot equal 2, so I'm going to be starting at negative 1. I'm going to be continuing up until 2, but not including it, union that with the set starting but not including 2, and going on until infinity. And there you should have it.